So I'm going to be talking about how you can use Temporal and MongoDB together to rapidly build robust applications. So it's tradition in MongoDB to present yourself using a slide in JSON, because we're a document database and conceptually we store information in JSON. So I am a distinguished solution architect at MongoDB. Just in case you can't read the JSON, I've been at MongoDB for a little over 10 years, and I've been working on document databases for about 15 years. I am brand new to Temporal. I found out about Temporal like in July, and I'll kind of tell that story in a second. So if you stacked ranked everybody's knowledge on MongoDB, I'm probably at the top of the room. And if you stacked ranked everybody's knowledge about Temporal, I'm probably much closer to the bottom. So kind of be gentle with questions at the end. And I have my contact information up there if you'd like to reach out after the talk. So how did I get here? So as part of my role as architect, I'm an engineer tied to the sales organization. And I work with a lot of customers, many of which are doing what we call legacy modernizations. They got a monolithic app. It's typically built on Oracle. And what they're trying to do is get to a microservice architecture. And that's great. That gives them lots of benefits of productivity and things like that. But what happens is we're pretty good at MongoDB with the data part. We can really help a customer very efficiently migrate their data to MongoDB, write the code for the data layer to access that data. That's great. What happens, though, is that they struggle with the microservice orchestration. And we've had lots of talks yesterday about customers running, Kafka queues, events, and being really hard to develop and debug and things like that. And that really impacts MongoDB because most of our business comes from a cloud platform called Atlas, which is a consumption-based platform. You deploy a Mongo cluster in Atlas, and the more data you put in Atlas, the more clusters you deploy, the more revenue we get. And if you don't do that, we don't get very much revenue. And what we can find is our customers get bogged down moving their apps into MongoDB and their microservice architecture because they're struggling with the orchestration. So a couple months ago, there was an email from one of our product managers saying, hey, anybody want to research Temporal and see if we should be working with them and how it would fit? And I did a quick Google search of what Temporal was, and I said, wow, this seems like a problem that would really help us if we could help our customers solve, and that's how I got here today. So just like in MongoDB, you present who I am in JSON, I took a cut at putting my talk agenda as a temporal workflow. So essentially, I have 40 minutes today, and they're going to kick me out in 5 minutes. I'm going to be talking about 4 things. One is why you should use MongoDB and Temporal together. I'll talk about some of the benefits of MongoDB. I'm assuming that everybody in this room knows the benefits of Temporal. The strengths of MongoDB are very similar and they're complementary, so I want to kind of make that point. And then we'll kind of walk through an example of how MongoDB and Temporal can be used together, and then finally talk about some future directions that we're working on at MongoDB. So let's jump in and talk about why you should be using MongoDB and Temporal together. So like I said, when you're doing legacy modernization, it really involves 3 things typically. You're breaking your app into microservices. You're also modernizing your platform, right? So most companies don't do microservice architectures and have their data platform be Oracle. Similarly, the orchestration layer, it makes a lot of sense to use a modern platform like Temporal. So we're doing modernizations at multiple levels. And then usually it involves the cloud as well. There's lots of advantages of letting somebody else manage your infrastructure, having the ability to scale up, scale down, those types of things. So it usually involves those 3 things. And we're doing this because we really want to get some benefits in terms of productivity, scalability, eliminate some of the complex operations, get resiliency, and sometimes it's even reduced costs, but not always. And the reason why this is happening is that businesses are insisting on that we roll out new functionality faster. From MongoDB perspective, they want more access to their data. If you have data locked in a siloed monolithic Oracle application, to get it out, you've got to ETL it to some data warehouse, and it's 24 hours old, and that's a huge problem. So they want better access to their data, and they want to reduce costs. So lifting and shifting is not, if you want to get these benefits, lifting and shifting is not an option. Just going from Oracle to Postgres in the cloud doesn't work. So you really have to do a re-architect. And in MongoDB, we have tons of case studies, be happy to bore you to death with them, of customers that have done this and got huge productivity gains, able to roll out functionality 3 to 5 times faster than they were before, and significant cost savings. So there's lots of value if you can do this right. And I'm going to go through these in a little bit more detail so you kind of understand why MongoDB is able to deliver these details, but they'll just that's a premonition of kind of things to come shortly. The real powerful thing, though, is if you look at Temporal, it delivers the same set of values, right? We're capabilities. It's enabling developers to do the durable execution much more simply, code like they were in college, as somebody said yesterday, not have to worry about all the complex error handling and things like that. And then it also enables you to build much more resilient applications. And then finally, if you're in the cloud, Temporal Cloud, you get the scalability. As your usage grows, the cloud is going to automatically scale with you. So you get the same values and capabilities in Temporal as you do in MongoDB. They're just at different layers in the application stack. So my strong belief, and I hope everybody by the end of this talk believes that, is that by leveraging the tools together, you get these kind of capabilities in terms of rapid development capability, robust, resilient applications that scale at both layers, both the data layer and the durable execution layer of your application. So I believe that everybody in this audience is convinced of all the capabilities of Temporal. Maybe you're not as familiar with MongoDB. So let's kind of dig into what MongoDB gives you these kind of advantages around productivity and resiliency. So my expectation, no, actually, before I go that, a little bit ahead. Anybody know what this is? Anybody? It's a ring. Any kind of ring? Wedding ring. That's what my wife thinks it is. This is actually one ring to rule them all, one ring to find them, one ring to bring them all, and in the darkness bind them. Now, why am I stating a little bit of Tolkien trivia? Because I'm expecting that someday in the near future, you guys are going to be in a room with your Agile team, and you're going to be talking about the capabilities in the next sprint, and the database guys are going to say, sorry, we can't make that change in time for this sprint. Either the schema changes are too complicated, we got to deal with the ORM, and there's all these stored procedures that are going to break things, or we're using our Postgres and Elasticsearch, and there's this 1 hour delay between when the Elastic indexes are updated in Postgres, and that means there's all this application logic to deal with the inconsistency, and we can't change that fast enough. And you guys on Temporal, you're like, we can do that in 6 hours. I just saw it yesterday, right? So you're not stressed by that. But the problem is your company is the loser for that, because you're supposed to get this functionality in, you're out in your 2 or 6 or whatever it is week sprint, and you can't because the database team is holding you up. So the reason why I think the ring is important, because you'll remember that guy from MongoDB talked about the ring from Lord of the Rings, and there's 4 ones I want you to remember. That's why I talked about the one ring. The first thing is, if you're using MongoDB, there's one representation, documents, JSON documents, that's capable of representing all your data. You don't have to use a special database for time series. You don't have to use a special database for like text documents, those types of things. So one database, one data representation that does it all. One query language that does it all. So with MongoDB, you can do full text search, you can do CRUD operations, you can do complex aggregations, you can do geospatial. You can combine all of those different types of operations all within a single query. Don't have to make a call to Elastic, to Postgres, join it together in your Java code or what have you. One query language, push all the execution to the database. Similarly, the corollary to that is one copy of your data. All of the data is in MongoDB. You can do full text search, you can do vectors, you can do time series, you can do aggregations, one query language, one copy of your data. Now, for full disclosure, we are going to replicate your data to different cloud regions and multiple servers and things, but that's all for resiliency. We're not ETLing data to different types of data stores, to a cache, to a search engine, to a vector store, to support the queries you need. You're only replicating for resiliency, not to support different types of operations. And then the last is we have our Atlas Cloud platform. So one platform, one administration interface that enables you to manage all of your clusters across all clouds very easily. So remember those 4 ones, and you'll be able to make an argument in that meeting on why you should be using MongoDB. So let's jump into that a little bit more. So this slide shows all of the enhancements that we've done in MongoDB, and if you give me 2 hours, I'll go through all of those bullets. Not going to do that today. Really, there's 2 main points I want you to get from this slide. From a database perspective, there are no features in your favorite database, Postgres, Oracle, whatever it is, that aren't available in MongoDB. So it's ACID. We have schemas. They are optional, but if you want to use schemas and lock down all your data in MongoDB, just like you do in your relational database, you're free to do that. We have joins, materialized and non-materialized views. Just about anything you can imagine are available in that. So if you switch to MongoDB, you don't lose any capabilities. You gain all these things I just talked about, and you don't lose anything. The other thing is, around the database, we've built all of this additional infrastructure so that you can do all the things I talked about, whether that is time series or full text search. We have our own BI tool called Charts. There's a mobile version of Mongo that syncs automatically to the cloud version of Mongo. There's just a whole suite of tools that enable you to build an application really easy, and it's all tied together by the single platform, the single query language. So this is just kind of the architecture slide of that, all of those different pieces tied together. I don't need to go through that again. But the real power here is that we're giving you a single developer experience that enables you to build just about any type of application really performantly. So let's kind of go into the technical details, since most of you are engineers. So always have to present this slide just in case you've never seen MongoDB, but we represent data in MongoDB very differently than your favorite relational database. So instead of organizing information in tables, we're storing information in documents. Documents are much larger conceptual constructs than tables. So in MongoDB, you tend to have one type of document, or in MongoDB, you organize documents into collections. They're kind of analogous to tables. So you tend to have one collection for every high-level entity in your application. So customers, orders, those types of things would all be documents. And in MongoDB, a single document can represent 5, 10, 15, 20 tables. So a document is a hierarchical structure. It's just, conceptually, it's JSON. We don't store it that way, but conceptually, it's JSON. And so you've got, like, that name field is a hierarchy of name and then has 2 subfields, but it can be nested as complicated as many levels down as you need. So you can represent complicated things like a credit report, or a mortgage application, or the purchase order for all the products that are required to run this conference, all as a single document. So we've got this nested data. We also have arrays, so multiple values, easy to handle in documents. You can just have fields that contain multiple values. They can have subdocuments, those types of things. And then the other powerful thing is that it's flexible. In MongoDB collection, you can have documents that all have different shapes. So if you have the credit reports, let's say for different customers, and one customer, works at a fast food restaurant, has almost no assets, and you've got another customer that, is a millionaire and has 3 homes, their credit reports, even though they're going to be dramatically different shapes, can exist together in the same collection. So it's just all about making things easy for developers. The other really cool thing as a developer, you can be writing your code in Java, have a Java class, an instance of that class, save it to the database. No ORM, no fussing, really it's just insert into database, and then you can run a query and get that Java class back. Again, no ORM, no mess, no fuss. Even if that underlying document evolves over time, just all works. So the other analogy that's required when talking about MongoDB is essentially parking cars in a garage. So another way to think about it, if you're using a relational database and you want to store a car, you basically got to take the car apart and design. You think about it conceptually, a garage, you're going to design all these shelves and things and little bins and stuff in order to fit all the individual shapes of that particular car, at least of its parts. And if you want the car back, you're going to do this n-way join to kind of pull it back together. Similarly, in MongoDB, we just store the car. You drive it into the garage, like your garage at home. You can, whether you own a Honda, Toyota, Tesla, a F-150, you can just pull that thing right in. The garage can store it. It's no big deal. MongoDB works just like that. And if you want the car back, you just say, give me the car with that VIN, and you get the car back. So from a development productivity perspective, it's really significantly a lot easier. The other thing I just want to reiterate, because a lot of people have looked at MongoDB a long time ago and kind of have misconceptions. MongoDB is an ACID compliant database. If you need to manage financial information, what have you, you're good to go. Begin transaction, execute a bunch of read and write operations, commit, they all commit atomically using snapshot isolation like you would expect. All right, so that's kind of documents. The next part of it is it's great to have this flexible database, but if you can't read the information, it's kind of useless. So one query language, one copy of the data, my ring again, does it all. So we've got this documents representation, and then no matter what type of query, complex aggregations, full text search, time series, geospatial, it just goes on and on. Really easy to do in MongoDB. So let's get into the technical weeds a little bit. This is a list that I put together of all the different types of queries that you can do. So you can do complex searches, find queries for data based upon top-level fields or fields nested in arrays and subdocuments somewhere, and you can put indexes on those top-level fields or fields nested in those arrays and subdocuments, so you can do those complex find queries very efficiently. Similarly, the query language allows you to do complex surgery on the documents. If I have a field that is an array of subdocuments and I want to find a particular subdocument for a particular line item in a purchase order and make a change to it, I can do that via the Mongo query language without having to pull that document into my Java code and edit it in Java. I can do it all via the query language, push the operation to the database, ensure the ACID properties of my operation like I expect. So we have geospatial. So we support a standard called GeoJSON. So if you have geospatial information in your documents, the location of your customers or your offices, you can do geospatial queries. We have one customer that provides roadside assistance, and they use MongoDB to match stranded motorists to tow truck operators, and they're just doing that based upon the geolocation of both the motorists and the tow trucks. So geospatial, we have about a couple years ago, we embedded Lucene into our architecture. So part of the same query language enables you the full capability of Lucene. So you can do full text search, faceted navigation, whatever you need to do right within MongoDB. And in pre-release right now, we've added vector search as well. So you can do, if you want to do similarity searches using embeddings, or you're building a Gen AI application, can do all of those types of queries directly within MongoDB. Complex aggregations. Any analytical style query you can do in SQL, you can do in MongoDB. In fact, we have a product called Atlas SQL that converts SQL to aggregation queries. So there's anything you need to do in terms of analytics, you can do via the Mongo query language. Similarly, we support joins. So we've had joins for a long time, but so just need to point that out. In MongoDB 7.0, I think there's something like 30 times faster So kind of leverage some of the optimizations that relational databases have had for years. They're now part of MongoDB, so you get that kind of performance on your joins. Still recommend using documents. Don't convert your tables to collections without doing denormalization. Use MongoDB, but we do give you the ability to do joins if you need to. And then I can't read some of those. Graph operations, as well as, so if you want to do friend of a friend style queries. And we also have special collections for time series data that both optimize the storage of time series, optimize time-based queries, and then also provide a whole set of operators like window functions so you can work with time series data. So again, one query language, one copy of the data, make it really efficient to develop applications. So I talked about all these great things about MongoDB, but let's kind of be honest about what the alternative is like, right? So you could build an application on, or a set of microservices on a relational database. I'm sure many of you all have. And that looks great, and it works in some cases. But what happens usually, though, is that you have to add additional data platforms to overcome the limitations of that relational database. You add Redis because those n-way joins I talked about with the car are too expensive, and you can't pull that car out of the garage over and over again because you're going to crush the server. So you want to store that car as a car, so you use Redis. So now, as an operations and development team, you've got to now work with multiple data stores. Then maybe you've got this really high volume of log data or audit data. The relational database can't have that, so you grab one of MongoDB's competitors, Cassandra or something like that, and you write that data to Cassandra because it can handle the volume where the relational database cannot. Or maybe you need to do graph or time series, and it just gets worse and worse because you need to do full text search. And just imagine how much burden that is for developers to work against all that, and how much burden that is for operations teams to manage all that. And it just goes on and on. Maybe you need to do mobile, and you need to start archiving this data in a data lake or data warehouse, and it's just it's complicated. And that's one microservice, right? So you could have potentially, dozens of these different stack topology composed of different data technologies to make your application work. Or, one ring to rule them all, one copy of your data, one query language, one data representation, one platform. Right? Those are kind of your alternatives. So I'm not going to go through MongoDB architecture today because I don't have that kind of time. But the points I want to make here is that from a resiliency perspective, MongoDB and Temporal are almost identical. So what I mean by that is in MongoDB, we replicate data across multiple servers. Those servers can be in different availability zones and cloud regions, so you get the HA properties. And then if failures occur, we will automatically fail over to the nodes in the other regions, just like the demo yesterday with having in Temporal Cloud, having your cluster in multiple regions. Identical to that. And just like Temporal, all of the retry and error handling is built in. So if you're a developer and you're writing code using the MongoDB driver, you can issue a write and know that if a failure occurs, what will happen is after the cluster fails over, the driver, you don't have to write any code to do this, will connect to the server that takes over, that's connected to, and ask, do you have transaction ID 12345? I never got the acknowledgement to that transaction. If the transaction's there, it doesn't have to do anything. If it's not there, it just retries it. Similarly for reads, you do a read, the server fails, you don't get a response back. Once the failover completes, the driver's just going to automatically try the read. We have customers who have experienced data center outages, and all their end users experience is just like a little delay while we're waiting. These failovers typically take like 5 to 10 seconds. In contrast, the relational platforms, there's alarms going off, they're scrambling teams to go and run all these scripts to do the migrations. MongoDB just kind of happens. And then when you fix the problem, the cloud region comes back, the network issue is resolved, it automatically just falls back over. Same process repeats itself in the other direction. You don't have to do anything. And just like Temporal, MongoDB scales horizontally. You can add as many nodes as you need to meet your query or data volumes. If you're using our cloud platform in Atlas, this is all, you have the option to have this can be completely automated. We just monitor your data size, your query volume, and scale your clusters as needed, both up and down, so that you don't have to manage the infrastructure. And then finally, just like Temporal Cloud, we have our cloud platform called Atlas. It is really the best way to run MongoDB. I think it's kind of pretty much known as the best data platform out there for managing data. Runs across all 3 clouds, provides a crazy amount of functionality. I encourage you all to check it out. So, I kind of gave you an overview of why I think MongoDB and Temporal essentially solve the same problem in terms of improving developer productivity, ensuring resiliency and scale at different layers, kind of in these microservice architectures. So before I was willing to kind of come up here and pitch this to you guys, I wanted to try it myself. So this is probably obvious to everybody in this room because you're Temporal users, but to a database guy, this was not obvious to me until I actually tried it. So essentially, what I had built for a demonstration environment, probably 3 or 4 years ago, I said, let me build a ticketing system using a microservice architecture. I built it twice. I built it once, well, actually I built it 3 times. I built it once using Postgres, using tables. I built it a second time using Postgres, using JSONB, and I built it a third time using MongoDB. And the reason why I did that is I wanted to demonstrate to engineers about how much easier and how much more productive you could be in contrast to those other alternatives. So that microservice application, or at least demonstration, existed. And I said, well, let me rip out the orchestration layer, because that was kind of a mess, and replace it with Temporal, and let's see how easy that goes. And it was like crazily simple, right? So all I needed to do was I created a Temporal workflow. I essentially created a set of temporal activities that reached out to the ticket service that already existed, that performed the operations on the database. I forgot to mention, when I mean ticketing system, I mean like a system like Jira that's tracking software issues, not something that's we're used to like purchase train tickets or something like that. So just to give you an idea, the way I built this kind of workflow is it's just ticketing system. We're gonna process this workflow and it's gonna end when the ticket's closed. And then it's just a bunch of if-then else's that are looking at the current state of the ticket. So we're gonna loop, essentially when the ticket's closed, we're done. But otherwise, we're just going to look at the state of the ticket and do different things depending upon what state of the ticket is, if it's unassigned, in progress, those types of things. So if we drill into a situation where we're waiting for the customer, right? So we've created the ticket, the customer's given us their comment, we've responded, and now we're waiting for the customer to respond. It's pretty simple. It was amazingly simple for Temporal. I just have to sit there and wait for the ticket status to change. So the ticket status is going to change when we're waiting for the customer. When the customer goes in and adds a comment, that's going to change the ticket back to like in progress or something. Or what could happen is the customer doesn't respond. That happens all the time. So we have to deal with that issue as well. And really, there's just another if then and else. If it's a timeout, then the customer didn't respond, so we nag them with an email. If the ticket status did change, then it's really just a matter of doing a little bookkeeping and going back through this loop and processing the next ticket status. So eliminated a whole bunch of complexity just with a very simple Temporal workflow. And then, so my real reason for doing this was to kind of figure out how I would connect MongoDB to this. So my create ticket activity is pretty simple. Just have a little bit of metadata that I'm managing, that we're using to manage the workflow, just the ticket ID and what the current status of and things like that. And then all we need to do is call that existing ticket service that created the ticket in MongoDB. And then it's pretty simple. The MongoDB code is like incredibly simple. Create the JSON object for the ticket, and then insert one, save it to the database. That's it. The really cool thing about that for people doing relational development, no matter how I change the structure of that ticket, whether I put 85 more fields, nested arrays, subdocuments, my database operation, that insert one, is identical. So if you think about over time where you're building more and more features into your ticketing application so that description of a ticket grows, my ticket service code doesn't change. Where if you're using something like Postgres, you're going to be constantly updating your SQL queries as you enhance or your ORM layer, or whatever it is, to deal with the fact that your underlying data is changing. So I want to talk a little bit about future directions because I think it's relevant to temporal. You can give me a second to kind of tie this all together. But there's two things I want to talk about. The first is MongoDB has a first tool we call Relational Migrator that helps customers migrate from relational databases to MongoDB. And that essentially what that does is it enables you to analyze your relational schema and build a document model in MongoDB. So figure out how, like early on I talked about, hey, we got a bunch of customer tables and we want to create a customer document. It gives you the ability to essentially select a set of tables and say, organize these customer tables into a customer document and grab the purchase order tables and say, create a purchase order document from those. And then it will migrate all your data to MongoDB. That's essentially the first thing it does. And then it also generates a little bit of the API code. You can think of it kind of like language-specific GraphQL type stuff so that you have the start of an API around your data. But the reason why I bring that up is that it's a real area for research from MongoDB right now to be looking at large language models, generative AI, to help make this whole process go faster. And the reason why I bring temporal up is that part of what my research team is doing right now is we believe that we can leverage temporal here, because if you think about it, if we have to ask generative AI to orchestrate the services by using a state machine, event queues, all of that stuff, that's a much larger ask, asking some AI to generate code for, than it is to generate code for a temporal workflow. So this is all research right now. I don't know if it's going to work, but that's kind of why I see value in temporal in that effort as well. All right, so just to kind of wrap up, and then we can take questions. What I hope I've convinced you today is that both MongoDB and temporal give you kind of the same set of capabilities at two different layers in your application stack. The first is around developer productivity. They both make developers significantly more productive. The second is around resiliency. They're both designed to do a lot of that error handling for you automatically. But from temporal's perspective, in terms of workflows and retries and handling kind of all the queuing for you under the covers, and in MongoDB in terms of having the resilient architecture with all of the query operation retries as well. And then lastly, they're both designed as scalable platforms. So as you grow in terms of number of applications or just the volumes of data queries and workflows in your application, they'll both grow with you. So from my perspective, the value here is that it's going to enable you to build applications faster. So neither the data layer nor the workflow layer become the bottleneck as you're building application functionality. So with that, I think I'm happy to take any questions that people may have.